Okay, so some more examples of how to solve projectile motion problems. And here we have a problem where we have an object that is still launched completely horizontally. So I have a motorcyclist, let's say a stunt motorcyclist, maybe someone you'd go and see at the circus or something like this. And the initial velocity of the cyclist in the bike is 4 meters per second. And the height from which they're leaving is 20 meters above ground. Can we find the time of this flight, the velocity final, right before they hit the ground, and their displacement? So the first thing that I like to do to set up these problems is an X and Y t-chart. And this is important because it separates all of my X and Y values, because we know that the horizontal motion and vertical motion are independent of one another. So I set this up the same way every time. And then any values that I know from reading the problem, I'll fill in after I fill in the values that are usually the same. So here's what I mean by that. We know for any projectile that the only force exerted on it will be force of Earth on it. So because of that, if we make a coordinate grid, down is negative, up is positive, right is positive, left is negative, then the acceleration in the y will be about -10. Acceleration in the x will be 0. So that means that the velocity in the x direction will not change. Now I know that the initial velocity is given as 4 meters per second. And what's interesting about this problem is that that initial velocity is all in the horizontal. So I know that the initial velocity in the x is 4 meters per second, and the initial velocity in the y is 0 meters per second. And as the motorcyclist falls, that y velocity will increase. As the motorcyclist moves over to the right during this fall, the velocity in the x direction will remain constant. So his final velocity in the x direction will be 4 meters per second. So even when he gets to here, his velocity final in the x is still 4 meters per second, and his velocity final in the y is unknown. Okay, any other values that I know here? Yes, I know this 20 meters is his displacement in the y, but I need to really think about this. If he starts at the top and he finishes at the bottom, then his displacement in the y in terms of a vector looks like this. So although the height is 20 meters, the displacement in the y is -20 meters because he falls downward. Okay, so I need to find time, v final, and delta x in the x. Well, I already know, well, let me go back to this delta x here. I already know delta x in the y is -20. So I still need to find delta x in the x. And in terms of v final, I already know that v final in the x will be the same as it was initially, which is 4, so I still need to find v final in the y. And of course we need to find time. So let's think about what we already know. In the y, we've got our acceleration and our delta x. So if we go shopping for some math models, let's see what we'd have. I've got my 3 kinematics equations to choose up here in the corner here. And looking at what I know, I think that I would be able to analyze the y motion using the delta x equation and possibly come up with time. Let's see how that works out. Delta x in the y is -20. The initial in the y is 0. So 0 times time would still give me 0. So I'm left with 1/2 negative 10 meters per second squared times t squared. Alright, so I come out with t squared equaling positive 4, and the units on this are seconds squared. I'd really like t, so I'm going to take the square root of both sides, and I end up with time equaling 2 seconds. And this is important for me because although I found time in the y, that's the same time in the x. So time is equal to 2 seconds. Okay, now I can find v final in the y. So I'm going to get rid of these formulas here. I'm going to analyze in the y, v final, v initial, at, and I'm looking for v final. V initial is 0, and I've got negative 10 meters per second squared times the time that I just found, which is 2 seconds. So v final is negative 20 meters per second. So now I know v final in the y as negative 20 meters per second. All right, excellent. So the last thing to find is the range here, or delta x in the x. So this is going to be an x analysis, and I'm looking for delta x, so I think I'll use that equation, the delta x equation. VOT plus 1/2 AT squared. But because acceleration is 0 in the x, that 1/2 AT squared will just be 0. So I end up with delta x is equal to 4 times 2. And a delta x of 8 meters. So I hope this was helpful when it comes to solving problems where we have these projectiles. Stay tuned for the next video. Will be a projectile that is launched at an angle. See you then.